All right, so today we are working with equations. Okay, so we're solving simple and multi-step equations. So to get started, an equation is a mathematical statement that says two expressions are equal. So here is an example of an algebraic expression, 2x plus 3y minus 4. And here is an example of an equation, 2x plus 3y minus 4 equals 7. Okay, so you have the expression, which is identifying everything, and then once you have it equal to something, that's when it becomes an equation. Okay, so to solve an equation means to find the value of the variable that makes the statement true. This is also called finding the root of the equation. Sometimes we can solve an equation by inspection, which means just looking at it and applying number sets. Okay, so this first one here, when we look at it, x minus 2 equals 5. Well, if you think about it, 7 minus 2 equals 5, so x has to be 7. Okay? So sometimes there's easy examples when you can just look at it and figure it out. Okay? But sometimes it gets more complicated, and we're going to go over some of those more complicated ones today. So down here, it says when we solve an equation, we need to move terms with variables to one side of the equal sign and constant terms to the other. This can be done by balancing. Okay, so this can be done, oh, it's supposed to be a B, by balancing the equation or by using opposite operations. So let's do some examples. First one, method 1 is we're going to do balancing. Okay, so here we keep our equal signs lined up. Okay, we want variables on one side of the equal sign and all of our numbers on the other side. So here we have a negative 5. Okay, and the only way to get rid of this 5 is to add 5, right? Because negative 5 plus 5 gives you 0. Okay, and then we still have our plus y. Then we have our equal sign, and over here we have negative 2, but because we added 5 on this side, we have to balance it by adding 5 onto this side. Okay, so you keep your equal signs lined up. Negative 5 plus 5 is 0, so we're just left with 1y. And over here, we have negative 2 plus 5, or you could say 5 minus 2, which gives us positive 3. So 3 is your answer. Now by doing opposite operations, we do the same thing. We keep our equal signs lined up. We want our variables, which are x, y's, and z's. So we want our y on one side, and we want all of our numbers, our constants, on the other side. So opposite operation, if we need to move this 5, okay, the opposite operation, the opposite of negative 5 is positive 5. Okay, so over here we're going to be left with our y, but over here we're going to have negative 2 plus 5. So all we did is we moved this negative 5 over to the opposite side of the equation, and we used the opposite operation. So positive 5, when you bring it over the equal sign, became a negative 5, when you brought it over the equal sign, became a positive 5. So we have y equals negative 2 plus 5 is positive 3. Okay? Same answer, negative 3 and negative 3. Let's try the next one. Okay, so method 1, we're going to do it by balancing. Okay, so we want to solve for m, so we want to get the 3 over to the other side. So right now, because it's multiplied by 3, we have to divide by 3. And if you divide on one side, you have to balance it by dividing by 3 on the other side. Keep your equal signs lined up. 3 divided by 3 is 1, so we're left with 1m. Then you have your equal sign, and 18 divided by 3 gives us 6. All right, let's do it with the opposite operations, okay? So over here, we have multiply by 3. Okay, so this right here means multiply. Okay, so if we're going to do the opposite of multiply by 3, that means we're going to have to divide. Okay, so that means m equals 18. Instead of multiplying, we're doing the opposite, so we're dividing by 3. And then m equals 6. What do you notice again? Same answers. Okay, let's try the next one. So method 1, we're going to have our balancing. So over here, we'll keep our equal sign lined up. So we want our x's on one side and the numbers on the other. So the opposite of negative 7, in order to get rid of negative 7, we have to add 7. So over here, we're going to have 2x minus 7, but then we're going to add the 7 to cancel. We're going to balance it. And so over here, we have a 9, but because we added 7 on this side, we have to add 7 to this side. So over here, negative 7 plus 7 gives us 0. So we're just left with 2x. Keep your equal signs lined up, and then 9 plus 7 gives you 16. Now, we have 2x equals 16. We have to solve for 1x. So we have to get rid of this 2 here. So in order to get rid of the 2, we have to divide by 2. Okay, it's the opposite operation. Okay, and we have to balance on the other side. If we divide by 2 on one side, we have to divide by 2 on the other side. Well, 2 divided by 2 gives us 1x, and then 16 divided by 2 gives us 8. Okay, or we can do it the opposite operations. So right here, we have this negative 7. We want to move it over. Negative 7 turns into a positive 7. So when you write your next line, your 2x stays the same. Then your equal sign stays the same. 9 stays the same, but we're opposite operation means you add 7. So we have 2x equals 9 plus 7 gives us 16. And now we have to solve for 2x. Well, the opposite of multiply is divide. So that means we're going to have x equals 16 divided by 2. And in your calculator, 16 divided by 2 gives you 8. Okay? Wow, magic again. Okay, so it doesn't matter which method you prefer, whether it's balancing or just opposite operations, it's going to give you the same number as long as you're following all the proper techniques, okay? So, last example here. Let's do the balancing. So we want our variables on one side and our numbers on the other. So right now, this is a negative 36. We want to get rid of this. So we have to do the opposite operation, which means we have to add 36. So over here, we're going to have negative 12g minus 36, and then add 36. My equal sign, it's hard to write small on these things, okay? So equals, over here we have a 0. But because we added 36 to one side, we have to add 36 to the other side. So negative 36 plus 36 gives you 0. So over here we have 12g, and then equals 0 plus 36 gives us 36. Now we have to solve for 1g. So because it's multiplied by 12, we have to divide by 12. And because we're balancing, if you divide on one side, you have to divide on the other side. So 12 divided by 12 is 1. So we have 1g. And then 36, sorry, I just noticed right here, this should be a negative 12. Negative 12. And if you divide by negative 12, you have to divide by negative 12 here. Sorry about that. I hope you guys caught that. And you were going to say, Miss, you forgot the negative sign. Okay? So then a positive divided by negative is negative, and then 36 divided by 12 gives us 3. So the answer is negative 3. Okay, let's do opposite operations. So over here, we want our G on one side, and we want the 36 on the other side. So this 36, negative 36, turns to a positive 36. So on the left side, we're going to have negative 12. I don't want to forget that negative again. And then equals, over here, we have 0, and then plus 36. So negative 12G equals 0 plus 36 gives us 36. And now over here, we have negative 12 times G, so the opposite operation is divided by. So we're going to have G equals 36 divided by negative 12. And then G equals positive 36 divided by negative 12 gives you negative 3. Ta-da! Same answer again. Okay, so next slide. Remember, pause and rewind as many times as you need, okay? In case I'm talking too fast. So this one, it says we can check a solution to an equation by substituting the root, which is the answer, okay, into the original equation and verifying that both sides are equal. Okay, so let's do this. So over here, we are going to solve. So I'm going to move this 6 over. So positive 6 turns to a negative 6. So I'm going to have negative 3m equals negative 9 minus 6. So we've got to simplify. So negative 3m equals negative 9. Take away another 6 gives you negative 15. Now we need to solve for m. So the opposite of multiply is divide. So m equals negative 15 divided by negative 3. And then negative and negative make a positive, and 15 divided by 3 gives us 5. So our answer is 5. Oh, my cat. Watch out, Boyd. 1 second. Sorry, my cat jumped on my thing while I was teaching. Okay, so m equals 5. So now we're going to do the check. Okay, so it says we can check by substituting the answer into the original equation and verifying that both sides are equal. So let's write the original. Negative 3m plus 6 equals negative 9. So negative 3m plus 6 equals negative 9. Okay, so I'm just going to draw a line down here. We know that this side already equals negative 9. So now we're going to take this and sub it in here. So negative 3, instead of times m, it's now times 5, and then plus 6. Negative times a positive is a negative. 3 times 5 is 15. And so it's 15 plus 6. Negative 15 plus 6 gives us negative 9. And what do you notice here? Okay, they are the same, which means we did it right. Woohoo! Okay. Next, when solving an equation involving multiple terms, like terms are collected on one side of the equation. Remember I said like x's or y's or m's are on one side, and constants, oopsie, I guess there's no s, sorry, constant terms on the other. Once terms are separated, we simplify and solve. Okay, so over here, I always like to start with my equal sign lined up. We're going to move this x over to this side. So remember, this positive 2x is going to turn into a negative 2x. And this positive 2, when you move it over, is going to turn to a negative 2. Now, you don't have to write these in there. I'm doing it just because we're still learning a little bit. I'm just going to move this down. Okay, so on this side, I'm going to have 3x minus 2x. Okay, because I brought that over. And then over here, I have my negative 4, and then that 2 came over and it turned into a negative 2. So now we're going to simplify 3x, take away 2x, leaves me with 1x. And negative 4 minus 2 gives me